You walk into a room and within seconds you already feel something about the people inside. Maybe you feel comfortable, maybe you feel tension, maybe you feel like you are being judged even though no one has spoken yet. The strange part is that this reaction happens almost instantly. It feels like intuition, like a quick personality trait or emotional instinct, but beneath that feeling something far more complex is happening inside your brain. Long before you consciously evaluate the room, your brain has already started reading signals. Micro expressions on faces, tone of voices in the background, posture, eye contact, even the spacing between people standing together. All of this information moves through the visual and emotional processing centers of the brain in fractions of a second. One of the most important structures involved in this process is the amygdala. The amygdala acts like an early warning system. Its job is to rapidly detect emotional significance in what you see or hear. If something appears threatening, unusual, or socially important, the amygdala reacts almost immediately, sometimes before the logical thinking parts of the brain fully process the situation. This rapid pathway exists for survival. Thousands of years ago, detecting danger quickly could mean the difference between life and death. If a movement in the bushes suggested a predator, the brain could not wait for a slow, detailed analysis. It had to act fast. Even though modern life rarely includes predators in the bushes, the same neural circuitry still operates today. Instead of reacting to animals, it reacts to social signals. Your brain constantly scans faces to detect subtle emotional cues. A slightly raised eyebrow, a tightened jaw, a brief glance away. These signals may be so small that you do not consciously notice them, yet your brain still registers them. Within milliseconds, the amygdala sends signals to other regions such as the hypothalamus and brainstem, which prepare the body for action. Heart rate may change slightly, attention sharpens. Muscles subtly tense or relax depending on whether the signal suggests safety or threat. Only after these rapid reactions begin does the prefrontal cortex fully engage. The prefrontal cortex is the part of the brain associated with reasoning, interpretation, and conscious decision-making. It attempts to explain the feeling that has already started forming. This is why first impressions feel so immediate. Your body has already reacted before your mind finishes analyzing the situation. Psychologists call this thin slicing. Thin slicing refers to the brain's ability to make surprisingly accurate judgments based on extremely small pieces of information. In experiments, people shown just a few seconds of silent video footage of a teacher were able to rate that teacher's effectiveness in ways that strongly matched the evaluations of students who had spent an entire semester in the class. The brain had extracted meaningful patterns from brief glimpses of behavior. This does not mean thin slicing is always correct. It means the brain is extremely fast at forming hypotheses. Sometimes those hypotheses are accurate. Sometimes they are biased by past experiences or stereotypes stored in memory. The brain builds models based on history. If certain types of expressions or behaviors were previously associated with negative experiences, the brain may predict similar outcomes when it sees those signals again. This predictive mechanism explains why two people can enter the same room and feel completely different emotional atmospheres. Each brain is filtering the situation through its own learned patterns. Memory plays a huge role in this process. The hippocampus constantly compares current sensory input with stored memories. If something in the present resembles a past experience, the brain activates similar emotional responses. For example, a tone of voice might remind you unconsciously of a past argument. Even if you cannot identify the connection, your body may still react with subtle tension. Your mind later constructs a story about why the person feels intimidating or unfriendly. What you experience as intuition may actually be memory working faster than awareness. The brain is not just detecting signals. It is predicting outcomes. When entering a social situation, your brain quickly estimates possibilities. Will this person be friendly or hostile? Will this conversation be rewarding or awkward? Will speaking up increase status or create embarrassment? These predictions help guide behavior efficiently, but they also create blind spots. If the brain predicts rejection, it may interpret neutral expressions as negative. If it predicts acceptance, it may overlook subtle warning signs. The interpretation of the same face can change depending on expectation. Another fascinating system involved in social perception is the mirror neuron network. Mirror neurons activate when you perform an action and also when you observe someone else performing the same action. They help the brain simulate the behavior and emotions of others. When you see someone smile, parts of your brain associated with smiling activate as well. When you watch someone express pain, similar neural circuits related to pain become active in your brain. This internal simulation allows you to understand the emotional state of others quickly. It is one reason humans are capable of empathy. Your brain does not just observe another person's emotions, it partially recreates them internally. However, mirror systems can also amplify group emotions. In crowded environments where anxiety or excitement spreads rapidly, people begin synchronizing their emotional states without conscious coordination. Your brain is constantly tuning itself to the emotional frequency of the people around you. All of these processes happen so quickly that they create the illusion of a simple feeling. You walk into a room and you just know something about it, but that knowing is the result of complex neural choreography. Visual analysis, emotional detection, memory comparison, predictive modeling, and social simulation all operate together within seconds. The conscious mind arrives afterward, assembling a narrative. You might say this place feels welcoming or something about that person seems off. Those sentences are explanations constructed after the brain has already done the heavy work. The danger comes when these rapid judgments become rigid conclusions. Because they feel intuitive, people often trust them without question. Yet intuition is only as reliable as the data that trained it. If past experiences were narrow or biased, the brain may generalize incorrectly. A single negative encounter can shape future predictions for years. The good news is that these systems remain flexible. Every new interaction provides fresh data. When predictions repeatedly fail, the brain updates its internal models. People who once felt threatening may become familiar. Situations that once triggered anxiety may become neutral. The brain learns continuously. The next time you walk into a room and instantly feel something about the atmosphere, remember that the feeling did not appear from nowhere. Your brain had already scanned hundreds of signals. It had already compared them to thousands of memories. It had already predicted what might happen next. And only then did your conscious mind arrive and say, I have a feeling about this place. And that feeling, however confident it seems, is always an interpretation. Never a photograph, never an objective reading of reality. Always a filtered, prediction-laden, memory-colored version of what your particular brain, shaped by your particular history, decided was most likely true in that moment. Which means two things simultaneously. First, your instincts deserve respect. They are not random. They are the product of millions of years of social survival coding, layered with every meaningful experience you have personally accumulated. When something feels deeply wrong in a situation despite no obvious evidence, that signal is worth pausing for. The brain detected something real even if language cannot yet name it. But second, your instincts deserve scrutiny. Because the same system that protects you can also trap you. It can generate prejudice from pattern recognition. It can manufacture threat from similarity to old wounds. It can cause you to misread a neutral face as hostile, a quiet person as cold, an unfamiliar environment as dangerous, simply because the brain is running an outdated model on current data. The work is learning to hold both truths at once, to take the signal seriously without treating it as verdict, to feel the feeling without immediately building a case around it. Because the most socially intelligent people are not those who trust their instincts blindly. They are not those who dismiss their instincts either. They are the ones who learn to ask, after the feeling arrives, is this perception or is this prediction? And then they stay curious long enough to find out.